Hello everybody and welcome to your next flip lesson. We're actually beginning a new unit. Our unit this time around for the next few weeks is going to cover equations and expressions. A lot of what has to do with equations and expressions is kind of like what you see on the screen right here. You have a number next to a letter, and we'll talk about coefficients, what a variable is, constants. We have things called terms. We're kind of going to dip our toes into the water of algebra, for the next few weeks. Our learning target today is you, the student, will write expressions that record operations with numbers and with letters standing for numbers. Sounds kind of confusing. You're going to be dealing with things like that. Okay, that is what we call an algebraic expression. Okay, so what is an expression? An algebraic expression is a number or group of numbers with an operation symbol, some type of operation symbol, plus, minus, multiplication, division. In this particular example right here, you'll notice that there really isn't any symbol, but it's implied. We have the 4p. Now 4p, when there's a number next to a letter, that means 4 times p. And we don't like to use x because it gets kind of confused for being another letter. So we use the dot, the binary symbol, for multiplication. But that's basically what you have there, an algebraic expression. An algebraic expression could be just a single thing, like 3n. That's an algebraic expression. X over 5, that's an algebraic expression. Now, to make sure that you guys understand, an algebraic expression doesn't really have an answer. That's another thing. No answer to it. X over 5. There really isn't an answer unless we know what x is, unless we know what the number is. But for the most part, these are left open-ended. There's no real answer to them. There's no real solution. It all depends on what you put in. So n could be anything. It could be the number of days that you worked out this week. It could be the number of calories in a hamburger. Same thing for x. X could be a lot of things. It could be the cost of a shirt that you bought. Keep in mind, algebraic expressions don't equal anything. And I'm going to kind of write this off on the side somewhere here, but if I had something like this, 4n plus 1 equals 9, for instance, now that is what we call an equation. And I'm really not going to get too much into equations, but make sure you're able to tell the difference between an equation and an expression. An equation actually has an answer. I can definitively say that n is 2. 4 times 2 is 8. 8 plus 1 is 9. Over here, though, however, there really isn't an answer. Like I said, it all depends on what you assign the value of n for. So, like I said, n could be a lot of things. N could be a lot of things. Let's move on. Now here, quite a bit. Now, what we're doing in this slide right here is we're looking at translating words into algebraic expressions. And what I have here is somewhat of a list here, multiplication there. We have a list of common phrases, common words that mean, addition, that mean subtraction, that mean multiplication, and also mean division. This is by no means all of the words. Now, there's lots and lots of words, but what I did right here is I compiled a list of the most common. So what you're going to want to do is stop the video and jot these down. You're going to want to have these in your notes. Go ahead and put these into your flip note. Okay, now let's go ahead and just get into translating algebraic expressions. And, the best way to learn how to do these is by basically doing them. Getting some practice in. The more you do these, the better you're going to get at them. Just by looking at them, doing a couple or watching me do a couple is not going to cut it. You're going to really have to do a lot of these to get used to it. All right, let's go ahead and start here. We have 8 more than some number. Now, the important thing that you have to kind of do with these problems is you have to be able to look through it and kind of weed through all the information. And one thing that just totally stands out to me is this more. That word more is a word that tells me, hey, there's going to be some addition here. So 8 more than some number. Now, when you guys see some number, a number or some value, something like that, that usually symbolizes that there's going to be an n. You can use whatever letter you want, A, an I, whatever you want. So, maybe avoid the letter O because it looks like a 0. But you'll notice that a lot of times in algebra, that words are sometimes scripted. But you'll notice I write my X's kind of like this so that it doesn't get confused with multiplication, An I, I'll write it like this, more of a scripted I. These, you want them. So back to this problem. All right, more. Back to this problem here. More tells us add. You see this kind of phrase, some number. That means x, okay, or whatever letter you want. So I'm going to write 8 plus x. There you go. Or x plus a. Order doesn't matter when it comes to addition at all. When it comes to subtraction, order matters. When it comes to multiplication, order doesn't matter. Okay, here's another one. 1/4 of a number. Now, this word of seems kind of harmless, like, it's just there, but that word of means a lot in algebra. It means a lot in math. Sometimes it basically just means of. Of means of. However, in math, of means multiplication. When you see the word of, a lot of times, 9 times out of 10, it's going to mean multiply. So 1/4 of a number. Now, we don't know what the number is, so don't just make up a number. Don't just write any number. We don't know what the number is, so we have to use a letter, okay? So I'm going to write 1/4 n, and that's it, or 1/4 times g. But I'm using a letter to stand for a number. We don't know what that number is. 4 times some number. It could be 4 times your weight, or not 4 times. It could be 1/4 your weight. It could be 1/4 of your age. It could be 1/4 of the number of calories you had yesterday. So it could be a lot of things. 2 more than 4 times some number. Okay, now this is a little bit more complicated. 2 more tells me that we're going to be adding 2. Now that word then, a lot of times, that's one of our switcheroo terms, which kind of tells you that things are going to be kind of switched around. I know that sounds kind of obvious, but 2 more is written first here. And if you have that word then, that kind of tells you, hey, you know what, write it after that. And what's written after that, here, you're going to write that before. That sounds kind of confusing, but that word then is our switcheroo word. So 4 times some number, I'm going to do 4n, 4 times some number, and then it says 2 more, so then I'm going to do plus 2. 2 more than 4 times some number. There you have it. I don't feel like you have to write a number next to a letter. If you want to write 4 times n like that, go ahead. There's nothing wrong with that. Like I said, though, avoid using the x for multiplication. 8 less than some number. Our next example here has the word then in it. Then, again, one of those switcheroo terms, which tells us that we're going to probably take this and put it here, and we're going to take this and put it there. Okay, this doesn't always work out this way, but many times it does. So 8 less tells me we're going to be subtracting 8. Some number means a letter, a variable. We don't know what it is. So the letter I'm going to use this time is A. Okay, and then 8 less means minus 8. Do not put 8 minus a. I know it seems like that. 8 less than some number. But that does not mean the same thing. That means the same thing. So 8 less, say the number is 10. What's 8 less than 10? 10 minus 8 is 2. And that would make sense. Okay, in our next example here, we have 5 less than the product of 2 numbers. And here we go. You're kind of hopefully getting the idea here that almost everything in an algebraic phrase, in a number phrase, has some kind of meaning to it. Even little things like of or then, they mean something. 5 less, he's going to go after that, and the product of 2 numbers will go before. We're going to switcheroo all that stuff. Now, what does this all mean? Product should tell us that we're going to be multiplying. Now, this is a little bit confusing, but it says 2 numbers. Now, the 2 numbers, I'm going to assume those 2 numbers are different. So what I'm going to do is I'm going to say the 2 numbers are A and B. A is one number, and B is another number. I know they're letters, but they stand for numbers. They represent numbers. And then 5 less than that would be minus 5. There it is. Okay, in our next example, probably the most complicated one, we have 2 times the sum of a number and 7. Now, when you see this word and, now I don't want you guys to make sweeping generalizations, although I am doing it. When you see that word and, that sometimes represents parentheses. So we're going to be putting something in parentheses. So 2 times the sum of a number and 7. The word sum stands for adding. It's the answer to an addition problem. A number, we don't know what that is, so we'll just say it's n. So the sum of a number and 7 would be n plus 7. And then it says here, 2 times that sum. So I'm going to put a 2 right up against it. I could also write this if I wanted to. 2 times, and then parentheses, n plus 7. But that's kind of a biggie there. You want to kind of pick that out. If you see that word and, not always, but a lot of times, that means you're going to have to put something, some kind of expression inside of the parentheses. Okay, in our last example, we have 7 less, which tells us we're going to be subtracting 7. Then, which means I'm going to probably take this and put it in the back. 3 times some number, I'm going to take that and put it in the front. That then switched everything around. So 7 less than 3 times some number. So 3 times some number minus 7. And that's all there is to it. These are not easy, I understand. Some of you have difficulty with these kind of problems just because of the sheer wordiness of it. And they are kind of tough. It's hard to kind of pick through it. But you'll notice here that with a lot of my examples, I circled stuff, I diagrammed, I drew arrows, and that's kind of like what you want to do. You want to kind of look at this, pick the expressions apart as much as you can. Now for this part of the flip lesson, why don't you go ahead and in your notes write down the algebraic expression for everything that's here. So 5 subtract x, the product of 10 and y. Pause the video, write these out, try to do these on your own. No peeking, no cheating. Try to see if you can figure these out, and then hit play to see if your answers match mine. It's okay if you don't have them exactly like me. For some of them, order does matter. For instance, 5 minus x, you better have it like that. Same thing with number 3. Should be written like that. For this one, I put parentheses in there. We had the word and. Now, there's an and here, but it doesn't mean the same thing. So the quotient of a number and y, the quotient of a number and 9, that just means division. So I can't really use parentheses in the same way I did in this problem. This was a switcheroo problem with the word then. That tells you right there that you're going to be switching that around a little bit. Everything is going to be backwards, basically. Okay, here's another slide. Why don't you try these out on your own again and just see how you do. Again, I'm going to go ahead and fill these out, but try not to cheat. Try to really do these on your own. See if you can figure them out. See how you do. Pause, and when you're ready to go over them, hit play. Okay, everybody, that does it for today's flip lesson. Hopefully you guys were able to go through these and understand them. They're definitely challenging, and like I said at the beginning of this lesson, the more you do it, the better you're going to get at it. So definitely stick with it. Try to just be persistent, keep working at it, and working at it until you get it. Sitting there staring at it, it's not going to help. You're going to have to really put your pencil on your paper and move it around and see what happens. There's nothing wrong with taking a risk in math. That does it. Everyone have a great night. See you tomorrow.